As spring approaches and the temperature ramps up, most people understandably tend to avoid the Tucson sun. But in the past few years, UA Professor Alex Cronin has spent a majority of his time out in it.
In 2005, I brought a physics class out here for a field trip, and we got a tour of the Tucson Electric Power solar test yard then. More recently, I learned that TEP wants the University of Arizona to be involved, to do some new research out here. So I've brought on board 3 students from the Department of Physics, and we're coordinated by AZRISE, that's the Arizona Research Institute for Solar Energy, to study how each different type of solar panel performs outside here in Tucson. One of the big challenges for solar panels is they're still very expensive. So which panel makes the most power per cost? So the most watts per dollar. That's a question we're trying to answer in order to provide information to homeowners who might want these on their roof. Another question we'd like to answer is, how long will they last?
Upkeep of the solar test yard falls largely onto the shoulders of students, who have spent months constantly building, upgrading, wiring, and testing the equipment.
Off the solar panels and everything, the power comes down through wires and these conduits and up to what we've been doing out here at the beginning of the semester is building these homemade custom boxes to measure the voltage and current and therefore the DC power that's coming off the panels. And this is where we can record data for the efficiency. This is where we can measure it off the wires themselves.
What I'm actually going to do today is calibrate this Hall probe so that we know that the amount of current that it's reading on the data loggers is correct. But in order to do that, I'm going to use a known power supply or a known current supply. And so I have to unwire everything in order to run a test wire through with 20 loops from this current supply. I'm working with rather low voltages, but I'm getting differences of approximately millivolt, which doesn't seem like a big deal, but you know, it adds up if you don't take it into account by averaging over time. And the more accurate we can get, the better for the public and the better for the project itself and the research value.